Hey everyone, welcome to another video by Python Pool. Let's continue our series in Matplotlib in Python. Today we're going to see some 3D plots in Python. We are familiar with the bar plot, we are familiar with the bar chart, the pie chart, the contour plot, and many of the plots we have seen in 2D graphs. But now we are going to see the same or some of these graphs in the 3D. So basically we are dealing with the three axes, the x-axis, y-axis and z-axis. First of all, we'll be seeing the line plot. That's the most simple plot in Matplotlib 3D. So even though Matplotlib was initially designed with a two-dimensional plotting in mind, but some three-dimensional plotting utilities were built on the top of Matplotlib's two-dimensional display in later version to provide a set of tools for three-dimensional data visualization. Obviously, 3D data gives you a more effective visualization techniques. Okay, so let's see in line plot graph, how could we design this type of graph in Python. I have my file ready. Now I'm just going to import some of the package. Okay, in 3D graphs we are going to use another awesome package from Matplotlib, that is mplot3d, which is initially present in MPL toolkits. So let's import that one. So from MPL toolkits, I'm just going to import mplot3d. okay, and after that our module, that is pyplot, basic module. So matplotlib.pyplot as plt, and then I'm just going to import the numpy. So these are my modules. Now I'm just going to define the figure class in the fig variable. So let's call the figure class here, and after that, now let's just define the access to this figure class. So plt, I'm just using the plt module for the access, not the add access module from the figure class. Okay, and I'm just giving the projection property as 3D. So we want a 3D graph. Okay, that's it, done. Now I'm just going to give the z axis, that is nothing but NumPy line space function, which is already present in NumPy. I'm just going to call that function and set the range from 0 to 1 with the gap of 100 square units. Okay, so then I'm just going to define the x function based on the z. So z into giving the sine function from NumPy, and sine function would be customized by 20 into z. So that's it. And in the y, I'm just going to copy it and just going to change the sign to cos. So here it is, the y, and I'm just going to change this sign to cos. That's it. Okay, now we have all the functions defined. Just going to call the plot3d function to give plot for the 3D graph. So just call the plot3d function from the axis, and after calling this function, I'm just going to give the functions which I need to pass, sorry, not functions, the parameters which I need to plot, and give the color as gray, simply. And after giving the colors, I'm just going to set the title also. You know what the setting title means. So I'm just going to set the title as 3D plot, okay, or 3D line plot. So let's get the line plot. Let's define the property, which type of plot we are plotting. And after all of these logics, I'm just going to call the show function, hit the save button, and see if it runs perfectly fine. It's not program, it's test. And after a while, it would be running. And you could see we got the exactly same graph as we saw in the presentation. Now after 3D line plot, let's jump to the another plot we see in 2D also, that is scatter plot. So a three-dimensional axis can be created by passing the keyword projection equals to 3D to the normal axis. So we know how to define a normal axis. We have done plenty of graphs in that one. So what we need to do, we just need to pass a specific property, that is projection, and set it to 3D to define a 3D axis in Matplotlib. And in the scatter plot, we use scatter 3D functions. So it would be scattering the values or the function values or the parameters, and would be defining the graph points accordingly. So let's see in Python how we define this type of graph. Okay, once again my file is ready. Now what I'm going to do, I'm going to use the same function as I used in line plot, but I'll be using some different functions and some different set of parameters. So let me just copy those functions from the test1 file. Let me just port that file so it would be opening. Let me just code it. Here it is, my file is. So I'm just going to use the same set of parameters. Let's just copy from here. Let's paste it here. And after that, I'm just going to define a variable that is C, which I require initially for the axis plot scatter, for the scatter 3D function to give. That is a default value I need to pass, and I set this C to x plus y. Now what I'm going to do, I'm just going to call the scatter 3D function, scatter 3D. I'm just going to pass the required parameters, this is x, y, and z, and then I'm just going to make the C equals to C as we gave here, and rest of the things I'm just going to copy it from here, paste it here, and just change it to scatter plot. Let's hit save. Let's see if it runs perfectly fine. And yes, it runs perfectly fine, same as we saw in the presentation. We obtained the same type of graph. Okay, now jumping to the another plot quickly. That's a contour plot. We have seen the contour plot in 2D. Now let's see it in 3D. So contour 3D function creates a 3-dimensional contour plots. And let's see this type of contour function or contour graph in Python. Now after my file is ready, I'm just going to import the required packages, that is from MP toolkits. I'm just going to import mplot3d. After that, I'm just going to import pyplot, matplotlib.pyplot as plt. And then I'm just going to import another great package, that is numpy as np. Now I have done with the packages. I'm just going to define the x and y function, that is nothing but the numpy line space function. Going to call, set the limit as -6 to 6 with the gap of 30 units. Same for the y. Let's copy it. Let's paste it here and change it to y, because I'm using the same data. Now my z would be defined by a function. First of all, I'm just going to define x and y that we saw in the 2D contour plot. Just if you remember, we were using mesh grid function and we were passing some of the values, that is x and y, and then in the z we are defining some set of functions. In this program, I'm going to define the set of function in another function. So I'm just going to call the function and the functions as simply f. Now I'm just going to define this function right here. So let's define the function here, f, which is taking nothing but the x and y, and then what it is returning, has a simple statement, single statement, which is returning something, that is calling the sine function from the numpy. And in this sine function, I'm just operating it with square root function from the numpy, and operating what? That is nothing but x square plus y square. So x square plus y square. That's it. So that's what I'm returning, and that's what the z contains. Let's make it capital so it would be looking nicer. Now after that, let's define the figure function as usual, and after that let's add the axis, plt dot axis, and let's set the projection as 3D because we want a 3D graph. And after that, call the contour 3D function. Let's pass the required parameters, this is x, y, and z, and let me set the value as 50 and the cmap value as binary. Okay, that's it. Now I'm just going to set the x, y, z and labels. So let's quickly call the functions. Set x label, let me set it as x, simply x. Let me copy it for 2 times again for the y and z. So copy it, paste it again. Let's set the y label, and let's set the z label, set the y label as y, and set the z label as z. That's it. Now title also, title is important, so set the title also. Let's set the title as 3D contour plot. And after that, in the end, what we're gonna do, we're gonna call this show function. Let's hit save. Let's see if it runs perfectly fine. Okay. And yes, it runs perfectly fine as we saw in the presentation. Okay, jumping to another plot for today's video, that is wireframe plot. I know we haven't seen this wireframe plot in the 2D function, but in 3D we're gonna see because it's great and actually easy. So we use plot wireframe function for this. So let's define this type of graph in Python. Once again, my file is ready. Let's import the packages. Import mpl from matplotlib as plt, and then import numpy as np. I'm done with the packages. Once again, I'm defining x and y. So let's again use line space function, and let's set the limits at -6 to 6 once again with a gap of 30 units. Same for the y. Simply paste it here, make it y. Okay, we are done with the x and y. Once again, I'm going to create the mesh grid. It is nothing but np.mesh grid and passing the x and y here. Once again, I'm going to define the function. So I'm just going to define the function and call that in z variable x and y. Let's define the function right here, which is taking two variables and returning a single statement. Return np.sign. That's it. And after that, np.square root also. And square root of what? X square and y square. Okay, that's it. We're done with it. Y square. That's what we have the function. Remove the comma after here. Okay, we got the function in Z. Now I'm just going to call the figure function as usual. Call the figure function right here. After calling, I'm just going to call the axis function also in the ax variable, and set the projection as 3 because we want a 3D graph. I don't know what means. Projection as 3D. And after giving that one, I'm just going to call that wireframe function. So ax.plot wireframe function, and then I'm just going to give the properties or parameters. You could say x, y, and z, and then set the color as black. I want a black color because it's my favorite color. And then after giving the sum of the points to just beautify it, I'm just going to set the title. Set the title as 3D wireframe plot. 3D wireframe plot, and in the end, I'm just going to call the plt.show function. That's it. Let's hit save. Let's see. Okay, I just want to call. Let's see if it runs perfectly fine. Okay, it has an invalid syntax because it is not from, it is import. So it's not from, it's import. Let's save. Let's see if it runs perfectly fine now. And you could see it runs perfectly fine. That's how we saw in our presentation. Now jumping to the another plot, that is surface plot in Matplotlib, and the last plot for today's video. So we'll be using plot surface function and passing the required parameters or arguments, and then we are going to define this type of graph today, okay, in surface plot. So let's see how can we define that. Okay, the file is ready. Let's import the packages. PL toolkits. Okay, let's import mplot3d and from import matplotlib.pyplot as plt, and then import NumPy. These are the three crucial packages. And after importing the packages, once again I'm going to set the variable. I'm going to use outer function today of the NumPy, and then I'm just going to give the line space functions for x. Okay, and then what I give to x, I'm just going to copy that in y using a single line. So let's see how could we do that. First of all, let's give the line space function and let the set the limit as -2 to 2 with the gap of 30 units. And after line space, let's give the np.ones function and let's set the limit as 30. Okay, so that's it. Now in the y, I'm just going to copy these with the translation. So x.copy, and after calling this copy function, I'm just going to call this t, so it would translate the values. Okay, I don't know why I got this. I am just going to copy function, then okay. Now define the z variable. It would be depending on x and y. I'm just going to use the cos function today, and cos function of course x square plus y square as our ritual, you could say. It's like a ritual, okay. And then I'm just going to call the figure function in the fig variable. So it's calling the figure function right here. Oh, it's figure. Sorry for my typos. And then I'm just going to call the axis function plt dot axis and set the projection as 3D. Projection as 3D. Okay. 3D. And after that, let's call the plot surface function. So let's call that plot surface function for the surface plot. Let's give the parameters as x, y, z. That's what we need to plot today. And some of the values that like cmap, I'm just going to define the cmap as viridays. It's another property of cmap. And I'm just also like to give the edge color. So let's give the edge color as none. I don't want any edge color. Okay, certainly I'm not going to give any edge color. Okay, that's it. Now let's set the title to beautify. Let me set the title as 3D surface plot. And after all, the show function as a ritual, or as we could say, the logic for our programming. Let's hit save, let's run. That's it. If it runs perfectly fine, and yes, it runs perfectly fine. That's what we want. Okay, so after these plots, that's it from this video. Hope you're having a great day ahead. Thank you.